1, function characteristics. And so we're going to do a really short definition of a function because that should be review. So this is each x has exactly one y value. Right, so that's the verbal definition. A visual definition would be passes the vertical line test. Over the course of the year, we talk about domain and range every single unit. So the domain is describes all x values included. Whichever x values that you use for the graph, the picture, the list of points, all of it, every x that's included. The range, same definition, except all of the y values that are included. Now you may or may not have been introduced to interval or set notation, so we're going to go over a few of the ways to write it, and this is how you're going to describe domain and range. You're going to use interval or set notation. Okay, so interval notation uses parentheses, brackets, and infinity. Set notation uses curly brace, and inequalities. Now we're going to start one-dimensional because that is likely what you have seen before. So we're going to draw a little number line graph here. And we're just going to do one quick example for each of these notations. So we're going to go open circle at +5, shaded to the left. And then we'll do closed circle, open circle. All right. One dimensional. X number line. And we're going to write it in the interval notation. Now, domain and range. Where does it start? Where does it stop? Where does this picture start? And we go left to right. Okay. Okay, so he says negative infinity. Now, so I'm going to add something to the number line because he's right. See this arrow? What's the most left number on the number line? 0, -1, -2, -3. Keep going and going and going. And so the most left number is negative infinity. Now, infinity is more of an idea as opposed to a number. It's a concept. Okay? Because it really means the arrow, keep going and going and going and going like you're never going to get there. Now, I am going to label the right side of the number line with positive infinity. Okay. Now I'm ready. Where does this start? Where does it stop? Well, the picture starts at negative infinity. So I'm going to do a parentheses. Parentheses is not included. The reason infinity is not included because you can't ever actually get there. It means keep going. Arrow. Parentheses. Now 5 has an open circle above it. That's a parentheses also. Okay, so look at this. Circle, open. Separate to open parentheses. That means not included. Open circle, parentheses. All right. Do I pick my pencil up? Yes. This is not continuous. I pick my pencil up. I see 2 sections. Union. 2 sections, 2 intervals. Now that 6, that has a closed dot. That's where the bracket goes. I like to think of the top bar and the bottom bar as equals, because it's equal to 6 because it's included. Starts at 6, stops at 7, but 7 is open. That's it. Interval notation. Just all you're doing is you're listing where does it start, where does it stop, where do you pick your pencil up. Start, stop, pick up the pencil. Start, stop, done. Okay, we're going to turn this same graph into set notation. This one uses curly braces and inequalities. Okay, so I'm going to start with a curly brace. Do your best. It's kind of like 2 C's with a point in the middle. Right? And then we're going to draw an X and a bar, straight up and down. This part translates as X such that. The bar translates as such that. And then we write the inequality that describes it. I see 2 pieces, 2 inequalities. Okay, I need the simplest inequality to describe just this portion. Yeah. Yeah, X less than 5. Cool. Pick my pencil up. So, or. Ooh, next piece. Yeah. Okay, he said X is greater than or equal to 6 and X is less than 7. Completely accurate. I want it written shorter. Compound inequality. Yes? No? Yes? Idea? No? 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 They already answered. Yes?
6 is less than or equal to X is less than 7.
Okay, do you see that? X is greater than or equal to 6 based on where I'm reading it from. X less than 7. That's your compound inequality. Look, where does it start? Where does it stop? X is between 6 and 7. That's a between inequality. It's a compound inequality. 2 of them written as 1. This is the right way to write it. You have to be as simple and short as possible. Even though when he said both of them and the word and is accurate, it's not as short as possible. This is the correct way to do it. Okay, so how does that translate? Literally, you just write the words. X is less than 5, or, well, I would like to say 6 is between, X is between, but you should say X is greater than, greater than, equal to 6, and x less than 7. I'm not actually going to have you guys write out the words, but that's what you would write. You would write it the way he said it, but this is the inequality I would like to see. Okay, couple things to note. Infinity is always open. Always. Always open. That's sort of the tricky one. So I'll just put it. Infinity is always open. Okay. We've got 3 columns. There's an inequality. Interval, set. We're going to fill in the missing information. If it is helpful to you, feel free to create a graph. Right? Sometimes the visual is helpful. Okay? That's the graph, the one-dimensional graph that goes with this inequality. So it starts at 6 and it stops at positive infinity. Both open. See that? Not included. Set. Right? 2 C's and a triangle in the middle. X bar, x greater than 6. It's almost like copying that inequality column for the set. You just add the curly braces to it. Okay. You have, let's start with about 4 minutes. See how many of these you can fill out. Then we'll come back and talk about it. All right, what questions do you have? Yes.
How do you write the set notation for number 4?
1, 2, 3, 4. Okay, so that is all real numbers. That would be the words. All real numbers. So the interval would be, it starts at negative infinity and it stops at positive. Everything. Okay? The set notation, there's a few ways to write it. I would just do this. The curly R or the bold R is the set of real numbers. That's it. Could you get fancy and do something with the curly braces? Yes. If the answer is all real numbers, it's one of those 2 things I would like to see. Okay? And most of the time, I'm probably not going to specify interval or set. I'm just going to say accurately describe the domain. You pick your notation that works best for you. Okay? Other questions? Okay, I want to write up a few answers so you can check, and we'll take a few more minutes and then see where we're at. I'll be honest, set notation, not my favorite. I find it kind of tedious and long. There's only a few times where set notation is more useful than interval. And that's not really until Unit 6. Okay? I would definitely focus on your interval notation. It is faster to write. 2 through 7. Oh. Okay, almost there. Notice that it's a 1-to-1 correlation. One interval, one inequality. So I see two inequalities, two intervals. You're going to have two inequalities. Okay, this one's, I gotta write really small. Ooh. I'll give you a minute to think about those last two rows. Maybe draw the graph, right? The number line graph. Maybe that might help you. An inequality that describes what you want. So that is right. As long as it's short, right? Don't give me like double inequality for like a between. Does anybody want to try to give me the set notation for this one? Yes.
X such that negative infinity.
Say the whole thing.
Like
Yeah, yes. Tell me the whole thing, and then I'm going to listen and then write.
negative infinity is less than x is less than 6, or 6 is less than x less than infinity.
Okay, yes. What she said is perfectly correct. I'm just going to take the infinities out because it's shorter to write. Okay, she said negative infinity less than x less than 6. I just wrote x less than 6. They mean exactly the same thing. Or x is greater than 6. They are both accurate. All you need for set notation, an inequality that accurately describes the range of values that you're looking for. And that was correct. I would not take off for that. It's just shorter if I write it without the infinities for the inequality. Okay? All right. Try that last one here. And then I'm going to give you a graph. And I want you to fill in the interval and the set that goes with it. Yes, algebra 2.
Sorry.
That's okay. Negative infinity, 2, 2, curly, x less than 2, or x more than 2. If I were to put this on a number line, it would look like this. Everything except for 2. Open circle at 2. Everything else. Notice how you have to pick your pencil up to draw that. That means that there are 2 sections. They just happen to like be in the same place, right? They start and stop at 2, but that's not equal to 2. Yes?
Does it matter if you
No, but if you write one inequality, typically you write the x first. But no, is it accurate? Yes. Okay. I said there's only one time where set notation is better than interval. This is it.
Oh, wait, you done drawing it?
That's it. Yeah, I'm done drawing it.
Oh.
Yeah, that's it. There's only one time that set notation is better than interval, and you've met it. There's like one other time, but it's not important. Is that a continuous set of values? No, it's just two dots. Interval. Inequality. Is that an inequality? No. Then you can't use interval notation. Doesn't exist. It's not an inequality. This is the only time where you would have to use set notation. X such that x equals 3 and 4. That's it. There is no inequality. Means there is no interval notation. Okay, examples. First one, it's just a little sketch. Kind of like what we did with our warm-up with the pictures. I'll just label the points that seem accurate or seem important to getting the right size and shape. Now we moved into two-dimensional. We're going to use the same notation. And so we're going to describe the domain, and we'll do interval and set, and we're going to describe the range in interval and set. Your choice, guys. Doesn't matter which one you use. I'm going to do the vertical line test because that's what looks at the x's. And this is a function. Yeah, passes the vertical line test. Domain is easier than range because with a function, 1x. 1x means there's no overlap. Where does my picture start? At -4. Where does my picture stop? Infinity. It doesn't actually stop. The arrow, it keeps going. Now, Laura said positive infinity. It is positive infinity. Remember when you plot your coordinates that this is a positive x in quadrant 4. That is positive infinity for the domain, which is the x values. And so it starts at -4. And it stops at positive infinity. Do I have to write it like that? No. I don't need to write the positive infinity. So I'm going to go interval, set. Right, this is the inequality. This is interval. This is set. When you start looking at your homework, just pick one notation. You should be able to go back and forth between them. Okay. Range. Oh, the horizontal line. The horizontal line is going to do the range. Okay, now we always go negative to positive. So I'm going to start at the bottom of the graph, which is where the negative y coordinates are. Where is the most negative y coordinate as I drag this horizontal line? Here. Yeah, I do see the overlap. Just pick the most negative part. Now, I have an open circle here. But over here, negative 4 would be included. Feel free to tell me when I make a mistake, guys. Okay? Negative 4 y coordinates included right here. So it's included. The overlap, it counts. You're only listing all values that are included. Is negative 4 included? Yes. It's included. Okay, so it starts here at negative infinity, included, still included, stops at positive 3. Included. Only open circles are not included. All right, set notation. Oh, that's range. That's y values. So write y. The overlap is the hard part. Okay? Range is the hard one to write because you're like, wait, do I make it included or not included? Did you lift your pencil up? No, you did not. Means it's one inequality, one interval. Okay, second picture. This is your last picture. Okay. Same thing, domain and range, both notations. Try doing the vertical line test for the domain. Try doing the horizontal line test for the range. First thing I notice is I have to pick my pencil up to draw this graph. So I'm going to have to look really closely because it's not continuous. I see 2 sections of the graph, means I might have 2 inequalities. So anyone want to try to give me interval notation for the domain? Sure, give me one.
Square parentheses.
Bracket.
Bracket. Negative 2 comma 1. Normal parentheses. U. Open parentheses. 1 comma infinity.
Yes.
Close parentheses.
Yeah, you can call the bracket a hard bracket, and you can call this one a soft one. Just vocab. Or bracket parentheses. Okay, you see that? Is 1 included? Do you have a closed dot anywhere on 1? Nope, not included. Okay, I can turn it into set. Whew, intervals faster. Okay, range. It's the hard one because I got a lot of overlap here. Included or not included? Closed or open? Now if it's closed once, it's closed. If it's included once, it's included. Any volunteers? Yes.
Hard bracket, -2, combo infinity, soft bracket.
Yes. You see, like, yeah, this endpoint's included and this one's not, but is -2 included? Yes. If you say yes anywhere, it's included. See this one that's open? Oh, but wait, it's got filled in over here, so it's included. The overlap is tricky. Basically, if it touches that horizontal line once, it's gonna be included. You just have to look at multiple places. Okay. Oh, Y, it's range. Okay, there you go.